Chapter 7, Section 3, the natural exponential function. So in this section, what we're going to do is we're going to deal with the inverse of what we dealt with in the previous section. In the previous section, we did the natural log. And so in this section, what we're going to do is we're going to deal with the inverse of that, which is your exponential. So if you remember from your pre-cal days that E is kind of like pi on your calculator. E is a constant that goes on forever and ever. It's irrational. But again, you do have an E button on your calculator, just like we have a pi button on our calculator. And so some rules that we learned in pre-cal are these. The natural log of E is equal to 1 because they're inverses of each other. E to the x is equal to y if and only if, that's what this terminology is, if and only if the natural log of y is equal to x. And that takes you back up to here. The natural log of E to the x is x. And then e to the natural log of x is equal to x for every x greater than 0. Okay, and so like I said, this is the pre-cal stuff. You can write these down on your index card, or you can memorize them. You may already know them. Who knows? Okay, and so the actual calculus part is this. The derivative of e to the u is e to the u du. And a lot of people want to do something with the original function, but you don't. The derivative of your original exponential function is your exponential function times the derivative of u. Okay, so for this problem, we have f of x is equal to e to the 3x. And so what we're going to do is we're going to take the first derivative of it. So f prime of x is equal to e to the u. The derivative of e to the u is e to the u times the derivative of u. And so what we're going to have, and again, do you have to understand coefficients versus exponents and so like that? So like that, it's a little bit easier when you're dealing with the exponentials. But anyway, to rewrite this, we're going to have 3e to the 3x. Okay, and so for this one, if we have f of x is equal to 1 over e to the x plus 1. Well, for the derivative of that, we can do the quotient rule if we want to. So when you do that, you're going to have low times the derivative of the high. And so we're going to have e to the x plus 1, low times the derivative of the high. The derivative of any constant is going to be 0, minus high times the derivative of the low. Now, the derivative of e to the x is e to the x times the derivative of x, which is just 1, plus the derivative of 1, this one, is going to be 0. And then all over low, low. So you have low times the derivative of high minus high times the derivative of low. Well, we're going to take the derivative of each one of these separately. And so the derivative of e to the x is e to the x times the derivative of x, which is just going to be 1. And then plus the derivative of 1, which is going to be 0. So this is going to go to 0. And that doesn't matter. So what we're going to have is negative 1 e to the x. You can write the 1 or what. No, it doesn't matter. And so you have e to the x plus 1 quantity squared. And that's all you can do to that problem. Alright, so let's look at this one. This one we have a coefficient of x times e to the negative x. So this one's actually going to be our product rule because we do have a product. So our derivative is going to be the first times the derivative of the second. The derivative of e to the negative x is e to the negative x times the derivative of negative x, which is not going to be 1 this time, but going to be negative 1. So be careful with that. So you have first times the derivative of the second plus the second times the derivative of the first. The derivative of x is just going to be 1. So when we clean this up a little bit, we're going to get negative 1x, just combining this negative 1 and this x, because there are it's a coefficient, so we're bringing it up front. So you have negative 1x e to the negative x plus e to the negative x. Now, something that we probably need to do is we need to get these into factors. And so if you remember from chapter, I think, 5, you remember that we got these into multiplication problem instead of an addition problem. So we're going to factor out a negative, because I don't like that negative leading coefficient. So we're going to factor out a negative e to the negative x. And so that's going to give us x minus 1. There we go. So I don't want that leading coefficient to be negative in here, so I'm going to take it out front, which is going to change our signs. All right. So this one, this is our chain rule, and so the derivative here is going to be 4 times e to the 2x plus 7, and then lessen the 4 by 1, times the derivative of what's inside. The derivative of e to the 2x is going to be e to the 2x times the derivative of 2x, which is 2, plus the derivative of 7, which is going to be 0, so that's irrelevant. Alright, and then these two I'm going to put together because this one has an exponent, so I'm going to leave it alone. But this one has an exponent, so these don't have an exponent, so I'm going to put those together. So 4 times this is going to be 8 e to the 2x times e to the 2x plus 7 cubed. And there's nothing else that we can do that one. Alright, so for this problem, this again is going to be a quotient, and so we will do the quotient rule. And so the derivative is going to be low times the derivative of the high, which is just going to be 1, minus high times the derivative of the low. And just remember, the derivative of e to the u is e to the u times the derivative of u, which is going to be x squared, so that's going to be 2x, all over low. Alright, so let's clean that up a little bit. We're going to have e to the x squared minus, if we multiply everything in those brackets together, we're going to get 2x squared e to the x squared, and then of course over e to the x to the 4th. Alright, so let's cancel out an e to the x squared. So that's going to go back to 1, that's going to go to 1, and this is going to go back to e to the x squared. So we're going to have 1 minus 2x squared over e to the x squared. So this one says find the derivative of e to the x ln of x. E to the x ln of x. And so our derivative is going to be, the derivative of e to the u is e to the u times the derivative of u. Now, our exponent here is actually a product. We have x times ln x, so we're going to have to use the product rule in here. And so we're going to have first times the derivative of second. Derivative of ln of x is 1 over x. First times the derivative of second plus the second times the derivative of the first. Derivative of x is just going to be 1. So e to the u times the derivative of u. So what we're just going to clean up these parentheses. And so we're going to have, actually this x and this x is going to cancel out. So we're going to have 1 plus ln of x. Alright, if we have f of x is equal to the natural log of e to the x. Well, if we remember from the last section, the derivative of the natural log is 1 over, the natural log of u is going to be 1 over u, so u is e to the x, that's our argument of our natural log, times the derivative of u. So the derivative of e to the x is e to the x times the derivative of x, which is just going to be 1. And so what happens is this actually cancels out to 1. But if you remember that if you take the natural log of e to the x, remember the natural log of e, those are inverses of each other, and so you're just left with x. And so the derivative of x, as we know, is 1. So you can either use your calculus or you can use your trig, and just remember the natural log of e to the x is equal to just x. And so f of x, if f of x is just equal to x, then we know f prime of x is equal to 1. But if you can't remember the log laws, then of course you're going to have to remember your differentiation rules. Alright, so this one we have some trig, and that's okay. Look at what we're taking the derivative of. We're taking the derivative of secant u. And so the derivative of secant u is secant u tangent u. So this is f prime of x. It's going to be secant u tangent u times the derivative of u. So the derivative of e to the negative 2x is e to the negative 2x times the derivative of negative 2x, which is going to be negative 2. Alright, so let's see what we can put together. This I can write as a coefficient before my trig. So I'm actually going to have negative 2 e to the negative 2x secant e to the negative 2x tangent e to the negative 2x. And that's all you can do. A lot of people may want to factor out an e to the 2x here, here, and here, but you have to remember this is a coefficient. These are arguments. So you cannot factor out an e to the negative 2x. So what I would like you to do is I would like you to try these problems, and this is, I think, let me look for just a second. 21, 23, this is 29 and 31. 29 and 31. It's covered up. On page 397, bring them into class if you have any questions.